We are back. We are back. We are back. We're back. We are back. We're back. We are back. We're back. What's up, everybody? Welcome back to the stream. I hope you're having a wonderful day so far. Hey, Mahan, welcome in, dude. How you doing, man? Yeah, we're gonna do Leet code warm up here. Let's get some people into the stream here. Thanks everybody for joining. My connection's all over the place. Quit lagging. Come on. Might have to stop the Twitch stream. Is it lagging, Mahan? How's the connection? Yeah. I gotta stop the Twitch stream. Let's see if that helps it. Now we're back. Yeah. Alright, we'll just keep going here. Yeah, I found this playlist. It's DMCA free, so. Alright, welcome in everybody. I hope you're having a wonderful day so far. Couldn't get the Twitch to, the Twitch was causing me to lag, so we'll try that again another day. Welcome in, everyone. Hope you're having a wonderful day so far. I'm feeling good. The sun is back out here in the Bay Area. You know, I just have been missed the sun, man. The Bay Area gets like 4 months straight of just straight cold and not relative cold to what we're used to here, and wind and rain, and man, it's just the seasonal depression is fading off. I'm feeling good. I'm feeling better, and I hope you guys are having a great day today. Let's go ahead and get the chat loaded up. Straight cold. Is that how it looks, really? Oh, wrong light. That's why. Forgot to change my light over to that one. Now that's much better, man. That lighting sucked. Sorry about that. Jeez, I look ghostly. I look almost dead. That lighting. This lighting's way better. All right. Mahan, how's your project been? It looked really good when you showed it to me, man. I've been busy at work. I've been releasing products for my company left and right. Pumping them out quite a bit, and so yeah, it's been a busy, but glad to be back here. All right, let's go ahead and get started here. So we're doing number 88, merge sorted array. You are given two integers arrays, nums1 and nums2, sorted in non-decreasing order or increasing order, and two integers, m and n, representing the number of elements or the length of numbers 1 and numbers 2 respectively. Merge numbers 1 and nums2 into a single array sorted in non-decreasing order. The final sorted array should not be returned by the function, but instead be stored inside the array numbers1. To accommodate this, numbers1 has a length of n plus n, where the m elements denote the elements that should be merged, and the n elements are set to 0 and should be ignored. Numbers2 has a length of n. Okay. So let me see here. want to see how this works. Let me return m here. I want to see what this does. M is 3. Solved it. So n is 3. Or m is 3, sorry. So m is the length of our numbers 1. So even though numbers 1 has a length of, so these are still ignored. Okay. Interesting. Okay, I have an idea of how I think I want to do this. Numbers 1 is a list of integers, and numbers 2 is a list of integers. Okay. Oh, but these aren't linked lists. These are lists. I thought these were linked lists. Oh. Okay, so we have to numbers 1, numbers 2, insert to output numbers 1, 2. I'm trying to think of like how can we do this efficiently, right? Do you know about the divide and conquer algorithms? This is a merge sort. Right, merge sort. Okay, so merge sort, we went over this before, right? So if we merge sort means we have a sorted section and an unsorted section. Right, the left is the sorted section, the right is the unsorted section. But in this case, we're trying to insert items. So technically our left is our numbers 1, which is already sorted. And our right, Okay. So if we are trying to do merge sort, right? We did merge sort in the Leet code. So how could I set this up initially? So are we gonna pop from numbers 2? Do we need to destroy numbers 2 basically, or? They already did the partition part, now it's the merge part. Okay. So do we want to go backwards, right? To push the least amount of items to the right. So while nums2 right? If nums2 index -1 so we want to do this while nums1 or nums2 we have m and n, right? So maybe we should do for I, well, nums1 is a longer array. It has 0, right? It has zeros. So we don't want to be evaluating on these zeros. But nums1 has enough capacity to store all of the values, right? I'll put nums1. Nums1 equals to 0. We're saying 0 in an array is this. They're saying that a number 0 or a value of 0 is technically 0. Okay, so for I in the range of, well, we're not wanting to take, we have to do the range of 3, right? So the range of m, because that's how many values we need to insert, right? We need to say first, if m equals to 0 though, we're going to just make nums2 equal to nums1. Oh, I'm sorry, other way around. Nums1 equal to nums2, and then return nums1 here. So if it's 0, we're just going to set whatever nums2 is to nums1 and return, because that is the sorted thing in this case here, or something like that. So we need to go over m though, because m, although our nums1 is m plus n in size for this array, they provide us m, which is a tracker of just the total values, and zeros are ignored, like in this case here. So if m is 0, or m is none, then do that. Now we want to iterate over the range of m, which is 1, 0, which is value of 3, so it'll be okay, so we need to iterate going forward over the range of m. So m is 3, so it's going to start with 0, 1, and 2 with these index values of numbers 1. We want to go of m plus 1 because we technically this part is already sorted, so we don't need to evaluate that condition. Well, what if this number is less than that number actually? Or sorry, this number is less than. So we do need to go over the range of m. Don't return, it's in place. Oh, don't return anything. Oh. Oh, sorry. Thanks for that reminder. So for I in the range of m, we say j and then we need to iterate. We don't want to get stuck in a loop. So we do want to go backwards though, right? So not M. So M would be 0, 1, and 2. We want to go, not with the 0, we want to go negative M. Wait. So if we want to go backwards 0, 1, and 2, we go I'm not sure. They give you numbers 2, could be possibility of none. Right. So we want to go backwards here. No, we want to take the value here of 2. We want to evaluate it against what? This one or this one? I mean, this one first or this one first? Which one would be more efficient, the front or the back of it? So range of M would go 0 to 1 to 2. Range of negative M would go negative 0, negative. So we want to go M range of 0 to M minus 1 with a skip of negative 1. So this will go 2, 1, 0. Right? For values of I. Right. Hey Tim, what's going on, dude? Okay, so we're gonna go backwards. Negative 2 or 2, 1, 0. Evaluating this value. So right, okay, so let's go back. Nice, Mahon, okay, sweet. Sorry, what does an empty list report again? Is it, if it's not none, it's, oh, it's just an empty list. So it is just an empty list, then just, right? Can you do that evaluation if it is just empty list? I'm sorry, my brain is not working right now. Yeah, just a list. Okay. And then for I in the range of 0 to m minus 1, go backwards, right? We're gonna have a variable here called swaps at the start is gonna be equal to 0. On every iteration, we're gonna do a swap, right? Into the new array. So swaps plus equal 1 as soon as we enter into this loop. Right? So we have swaps is initialized to 0. As soon as we enter this loop, we increase swaps by 1 because we know a swap is going to take place within here. And we need swaps to be a positive value because we're going to need to move either the 3, the 2, or the 1 into one of these placeholders. So, that being said, is the music okay? You guys want to be louder or quieter? Let me know. We're going to say and then we're going to look at the highest values. So why would we even need, oh, because these are just by chance 3 and 3, but they could be different. So we need to say that J is going to be equal to N minus 1, right? Because it's 0 indexed. So J is going to be equal to N minus 1. We're going to pick up this 6 in this numbers 2. Right? This is the numbers 2 pointer. Right? And then we're going to say if
for relaxing times, make it Centauri time.
Numbers 1 index of I is if the 3 is less than the 6, then the 6 goes right there. If is less than numbers index J, right, then we're going to say that the 6, that nums index of, in this case, M, right, which will be 3, which will be here, so we say so I need a different counter because I don't want to reduce M. Right, I don't want to mess with my value of M. If I reduce M inside of this loop, does that affect this as well? The for statement?
Sounds relaxing.
Right? Like a while loop would? I think it would, right? So let's go also do this. Let's say that new M is equal to M at the very beginning. Right, so we need to, because we need to have an M starting place, and then we need to increase M to find the next insertion point or swap position, basically. Right? So yeah, new temp, make temp, yeah. Okay, so now if it's equal, then we'll go here and we'll add, I'm gonna say this is gonna be, so actually I'm gonna make this be 0 at the first because M is, because of 0 indexing, we can have swaps actually be 0 at first because we want to swaps at new M plus swaps, right, is going to be equal to the nums at index of J, right? So the greater value will be placed at there. If they're equal, well, we can do the same thing, right? Well, no, because let's say you have the 6. You're comparing the 6 to the 3. It's obviously larger, so the 6 goes there. Let's say this 5 is a 3. Let's pull the 3 out. Oh, and that's bigger than 6, so we push that one over. Oh, hold on. So if the current value of the 3 is less than the 6, which it is, we save that one here. So let's solve the other condition first. I think that one might help us. So if nums index I is greater than nums index j, this is the harder part. So if the case of this was a 2, let's say, instead of a 6, just imagine. We're saying, okay, the 2 is greater than the 3, so we need to push the 3 to the m plus swaps, basically. So with that, then nums temp equals to nums index I nums index of so if it's so if this is a 2, it's obviously less than the 3, so the 3 has to be placed in, so nums index I is a temp, and we need to save that at nums index new m plus swaps. Right, is going to be equal to temp. Right, we save that at the next available position. So let's say that this is a 2, and this is also a 2, and this is a 2. Okay, whatever. So this is a 2. It comes up. Okay, the 3 gets pushed to here. And then what happens to this position here? Well, we need to save nums index I is going to be equal to that value. Well, no, because we still want to keep going. So we need another loop then. We have to say while, right, while nums index I, or sorry, so let's do this. While nums index j is less than nums index I, right? That just makes more sense logically. We're going to continually push these numbers into these placeholders while this value, this 6, is greater than or is less than these other ones. Sorry. So let's say that this is a 1 here. Well, it needs to move down, so we need to continually push these. So then we grab the 6 on nums index I, right? We grab the 6 and we say, okay, this one is greater than here, so this won't even enter the loop. Okay, so this won't even enter the loop on this condition, so at the end of it, we have to then say do we need a condition to say if it's less than, then keep going? Mahan, bro, you're giving too much away, my friend. Like, I'm trying to figure this out. Please don't spoil. I know you're not spoiling yet, but you're honestly heading down that path. Like, if you're starting to use length -1s and stuff, then, you know, it's probably giving too much away here. Okay, so how do we want to do this? So while numbers index j, the 6, is less than, we're going, so let's say this is a 2, well, it's less than, we need to take temp is equal to so we need to take the 3 and swap it with what? What do we swap it with? The 0? No, we don't put 0 there. We fill here. If it's less than this one, okay, accept the struggle here. Okay, so we need to continually move values over so I want to take the 3 and save it as this value. Well, what happens to here is the 3 stays though. And then what do I put in the 3's place if it's less than? So I at this point crap. So if I move the 3 into this spot here, so what happens if it's less than right up front? So if nums index j is greater than nums index I right off the bat, then we can just save nums index of new m plus swaps right? New m plus swaps is equal to nums index j, right? Then we need to do swaps plus equals to 1. Ooh. And then go Oh, shoot. 3? Really? Gosh. No, good, Wing Hong. Appreciate the help. Just, I really like to do these Leet code problems. At least give them like a good hour and a half. I know people say sooner, but I'm in no rush. I really like the gratification of solving them. It's like those puzzles on like YouTube that people solve, like the magician puzzles. Okay, swaps. Then we save new m will plus equal 1 as well. Right, because we increase swaps to 1 and we increase new m by 1. Okay, else, so if less than or equal, but what if it's equal? If it's equal to the value, like if it's equal to the very middle, oh, shoot, like what if it's like the 2 here, so you go 6 goes to here, the 5 pushes the 6 to here and gets saved here because it's not here. So then we say elif nums index j is less than nums index I while it is less than, right? We are going to yeah, 88. Hey AJ, welcome in. Skullmaker, what's good, dude? Wing Hong, welcome back, man. Hey Tim. You giving it a shot, Mr. Tim? Alright, so are we on the right track here, you guys? At least give me that. So elif, if it's less than, so we could probably remove this line and say if it's equals to, then we need to do something, but then we'll just say this, else, right? Because then we can infer that it's less than, so while it's less than, so I have to say something here for the time being. So while it's less than, what do we need to do? We need to, so in the case of the 2, we have the 6 gets put to here. We are going to, so now we have nums, new m is 4. Oh, well, why are we doing this? Yeah, so we don't need this. If we're increasing new m, we don't need swaps. So if we're increasing new m, because we don't want to, yeah. So this goes to 4. That means the 6 gets saved here at new m, which is through index 3. So 0, 1, 2, and 3. We increase that to 4, so that's the next available spot that we're going to move here. And so the 5 comes along, and we see we have a 6 here. We then move the 6 while we take the 6 and move it to the next position. So while it's there, we're going to take nums index of new m will be equal to nums index of I. right? That'll push that one there. So now we have, well, we have a 6 and a 6. We need to get rid of this 6 value. So that will then, now, well, we need to get rid of it after this happens. Once it is less than, after this breaks, we will then put the value in its place. So what index is that? So that we have 6 here, and we have a 6 here, which is 3, which is the current value. Our new m in this case is 4. Well, because we need to reduce down we need to reduce down I quite a bit. We need to keep reducing down I during this loop. So new I is going to be equal to I. This is going to be new I. While it's less than new I, we'll save at new I and then decrease I by 1, or sorry, new I by 1. Right, so we can't mess with I because that's currently associated with our for loop here in this side of this while. So we're going to continually move. We have the 6 and the 6. So we put the 6 in, the 6 gets put here. Now we're on the 5, right? Because j is minus n, so we have to reduce j. So j also needs to be reduced. Try to j minus equal 1, except for a index error, or except for a if, so let's do this here, actually reduce j, right, if j less than 0, break, right, that means there's no more values. Okay, so now let's go back to our loop here. Final exam. Okay, so in the while loop, while it's less than, we're going to say, so we have 6 here. The 5 comes in, pushes the 6 to here. So we have a 6 here as well. We come here, oh, we can't do it. So in this case, let's go through our loop. So the 6 gets put here at position of new m, which is 3, index 3, and new m increases to 4. So this is the next position. So the 5 comes along. Oh, it's less, so it realizes it's less than this value. So we put nums at index new I, or which is equal to I in this first iteration. The 5, or sorry, the 6 here. We put that, which is at index. Oh my gosh, this is getting it. Need to turn off the music. Gotta focus up here. Gotta lock in. So the 6's here are new m increases to 4, index of 4, right? We then say, okay, it's less than this, the 5 is less than the 6 at, right? So we take the 6 at index of new I here at the first pass, and we put that at new m, which is at index of 4. 0, 1, 2, 3, 4. Now we have 6 and 6 with new m being here and new I being here. We then decrease new I down to here. Oh, this loop breaks because it's no longer true that nums at new I, nums 1, is less than that current value of 5. And so I'm just going to put this here to visually tell me we're continuing here on that current pass of J. So the 5, so on the break, when that doesn't come true, so let's say that this is a 2 here, well, the 3 then will be saved at new I, which is, no, at new M. No. Oh, shoot. Nums index J. I'm trying to use these variables, but my brain is dead. Okay, well, nums index J is less than new I, which is the current value of I, which is going to be here. Nah. Alright, think, Mike. Think. My brain is getting fuzzy. I'm gonna go get a refill on my drink and we'll keep thinking about this. Hold on, I gotta think about this. Think. Hold on, maybe some pretzels too. Okay. You guys had these pretzels before? These are so good. These are killer. Okay. So see, while numbers at index I is greater than numbers at index j. Let's bust out the whiteboard. I pounded them. Okay, so let's see here. We have 1, 2, 3, 0, 0, 0. And we have 2, 5, and 6. So we're on the 6. Okay? Right here, this is going to be I. And this is going to be, right, this is going to be J. Okay? I is going to be, in this case, equal to right? 2. And J is going to be equal to, right? We just had J equal to n minus 1. So this will also be equal to 2. Okay, in our first pass here, we take the 6. Okay, if J is greater than I. Well, is J greater than I? Yes. So we're going to be in here. Numbers at new m. New m is equal to m in this case, which is 3. So we say nums at new m, so nums at, this is new m here, right here, nums at new m becomes nums at j. Boom. Right? So that's that pass there. Okay? Now new m equals to 4 now. We have 1, 2, 3, 6, 0, 0. We have 2, 5, 6. J goes to here at 1. And then
that's all it is. I make it straight from the heart. So it's like, to be taken for anything else is crazy to me.
Cooking soul.
Right, we don't need to evaluate that. So, right, that finishes this. Decreases J by 1. Now I would go to 0, no, to 1 here. No, we don't want to do that. We don't want I to go down to 1. So what do we want to do? I doing this, but I got to. Okay. Let's first deal with the less than case. So let's clear that out. Let's find a different example where we have values that are less than. So let's do 1, 2, 3, 0, 0, 0. And then let's do like 1, 2, 1, right? So J is here, I is here, right? We don't want to decrease I because we need to evaluate the number on I every single time, because 2 will become I, or whatever gets put here at I. Hey, what's good, Edwards? Okay, so we're on the 1. We evaluate. Is 1 greater than 3? No. Is greater than or equal to? No. Is 1 greater than or equal to 2? No. Is 1 greater than or equal to 1? Yes. So what do we need to do? So, okay, if it's not, what do we have to do? We need to take nums at index I or index M minus 1. So take nums at index I and move it to the next value. Right? So if nums 1 index of, if nums 2 index of J is less than nums 1 index of I, then or we can say while nums 2 index of J is less than nums 1 index of I, right? That's going to start the loop, so we need to initialize these variables. So at the start, J is going to be equals to n minus 1, and then I will equal to m minus 1 as well. So while this value is less than J, we need to take the 1, we need to take the value at I and move it over to the current value of M. So nums index of M will equal to nums index of I, right? So that'll push the value of I. So this right here is the value of M at this pass. that'll take the 3 and put it here, right? Okay. If you break out of this, so what do we need to update though? So then we need to evaluate this variable here. Right, so we need to move inside of this loop the variable of I down to 2 to evaluate if j a value of 1 is less than this value here, true. So we need to initialize temp is equal to m minus 1 as well out front here, and then say temp here, oh no, sorry, temp here, and then we set to m, we increase m plus equal to 1 right off the jump because now m increased in size. It's less than the 2. So what do we need to decrease down? Temp right now is I, this is now temp. Temp will go down, right? And our m goes up. Not on this pass, at the end of the pass, when it gets inserted. We don't want, right? So then temp goes down. So right now currently temp is m minus 1, which is 2. It'll go down to index 1. We evaluate if this is true, then set index of I, which is currently hard-coded. It was stuck here in this loop at, as well as here. Temp will move down, I stays. This is currently a 3. I'll save the 3 over here. Now we want to save the index of temp. Right? So that'll continually keep moving those forward. Right, we're feeding in values from the back. Moving forward. So now we get to, now in the second pass we have 1, 2, 3, 3, 0, 0. Our I is still here, right? Our I is still here. Our M has now increased to here. So after this loop, we need to set num's index of I equals to num's to index of j. Increase m. Right. So maybe we don't even need some of this, like in terms of, maybe it's more simple than I thought. I don't know. So j minus 1 is the last number in nums with the last number. So in this example, let's go back to our example here. So now we also have 1, 2, 1, and we're on this guy here. So temp is equal to m minus 1. So this is now temp, right? So it'll say, okay, is 2 less than temp? Yes. 2 is less than the temp. J is less than the temp. Okay, this is J. It's less than the temp. So the temp gets saved at n. 3. Okay, the 2 okay, next, so then temp minus equal 1. Temp goes down. So we need to evaluate here. So now temp moves to here. Right. We evaluate, are you less than here? Yes. So this, although it's the same number as was before, this gets overrode to here. Temp goes down. Are you less than this? So it'd be less than or equal to, you reduce it down. Right, so it is. So we get rid of this. Right, and then put this here. So then our next pass, we have 1, 2, 2, 3, 3, 0, 1, 2, 1. Our temp is no longer here anymore. So at the end of this, we need to reset temp back to okay, so we need to say for I in the range of 0 to n minus 1 negative step. J is n minus 1. Temp is this. We save I at the end of this loop. The end of this loop. Well, I feel like I'm almost there. I don't know. Like So we're going to print on this value. Okay, so we do want to increase m because we want the loop to go one more step further, one more step further, one more step further. Right? So now we have this, and we're evaluating here. So in this case, our temp value, our j is 0, because we have so we also need to update j minus 1. If j equals to 0, we're going to break. No, if j is less than 0, we're going to break. So what we're doing is j is 0 here. M in this case is here. Temp in this case is m minus 1, which is here. I in this case is 0 to m minus 1 with a negative step. So if we increase m, what happens on every pass? Does I increase by 1? So this is the part I'm having trouble with. I don't know. Okay, so I don't want my eye to keep moving. I want my eye needs to stay. So in this pass, what is my eye? My eye would be 0. So let's set I is equal to m minus 1 and say while I is greater than 0, greater than or equal to 0, right? If you right? So if I is 0 here, well, it wouldn't be 0 because I is always greater. I starts off at this position here, right? And will increase to position say oh, do we even use it? Which is I. Oh, so let's remove this. Back all this up. Put temp here. No, we're not even using I. Because temp reduces. You save it at that temp. Okay, so in this pass here, you're at the 1, okay, which is J. Ugh, this is so annoying. So we have 1, 2, 3, 0, 0, 0. And then we have up here, it's our other list, which is going to be 1, 2, 1. Right, so J starts here. This is our temp variable here. If J is less than 0, break. That's not true. So J is, we don't have a J. J is not less than 0. So we, oh God, struggling through this one, guys. Are you guys working on this one too? Okay, so we're on a 1, which is J, right? J is not less than 0 in this case. J is a 2. So we say, okay, J is also numbers index J, which is 1, is less than or equal to numbers index temp, which is that is true. In that case, numbers index M, right, which is given in the problem as this is also M. Numbers index M, oh, I'm sorry, M is one step forward. M is here at 3. Right? Numbers index J becomes, so the 1, no, this 3 comes over to here. Right, so now we have 1, 2, 3, 3, 0, 0, 0. Okay? The 1 is still less than this 3. The number is still less than this 3. No, it's still less than the 2, I mean, because we already evaluated temp here. Temp gets moved down to here on the next pass. We evaluate the 1 against temp. It's less than, so the 2 goes here. Now I have 1, 2, 2, 3, 0, 0, 0. Okay? Which this is now our temp. Right, and then M is still This is still going on. Nums at index n. So if it's less than or equal to, oh my gosh. This one's tricky. This one's tough, man. I thought this one was not gonna be that tough. I thought it was a linked list problem. Got some more pretzels here. Ba-da-dum. So let's code as we write, I guess. Okay, let's think about this. Maybe do a little bit simpler. 1, 2, 3. I'll do 1, 2. I'll do 1, 3, 5, right? 0, 0, 0. And the list we want to merge is going to be 2, 4, 6. Okay? So, what is the first step we need? Right? The first step we need is that we need to get the index value here of m minus 1, and we need to get the value here of n minus 1, right? So, and then what kind of loop do we want to do? Do we want this value to change down and down? No, because we need to loop over while m So let's stop when m becomes greater than, right, n plus m. So while m is greater than m plus n, sorry, while n is less than or equal to this, what are we going to do? Okay, we are going to say that j is equal to, above this we need to say that j is equal to n minus 1 and that I is equal to m minus 1, right? Okay. So then, so currently, and our m is here. So m is less than or equal to n plus m, right? This is n plus m. So that checks out. Inside this while loop, we'll say while nums one index of, let's say that temp is equal to I, right? While nums index of temp, we'll say this is also going to be equal to temp is equal to
Cooking soda.
I don't want to make an alias, I want to make a new thing. So you have to check everything, right? So m minus 1. So while numbers of n minus 1, so the 5, is less than, and while numbers of index over j is less than numbers index of 1, temp less than or equal to, we are going to then take the value of m minus 1, which is temp in this case, and save it into the place of m. So then on the next pass, well, I don't think we should do that, because then yeah, so we'll save it into m. Well, in this case, what it, like this 6 this doesn't equal to it. God, dude. So we have if nums index j is greater than nums index of I, we're going to then save nums index of m equal to nums index of j. We're then going to say m plus equals to 1 . So we need a new m here. Right? So if it's equal to, if it's greater than, if the value of j is greater than I, the one we're trying to merge in this case is 6, we're going to place the 6 at m, which is over this 0. Increase m to this 0, and then continue the loop from there. Right? Elif nums if it's less than, well, it's less than or equal to the current value of m, which is 3, which is now nice down to 2. So nums is less than this. So while the 6 now got put here. Okay. M got increased to here. m minus 1 got increased to here. Now on the 4. 4 is less than so it's not greater than 6, so that doesn't come true. So it's less than the 6, so while it's less than temp, which is m minus 1, we're going to then move the 6, it's less than the 6, so the 6 goes over to m. So nums index m becomes nums index j. M is here at this 0 place. This 6 would get moved over. Then we'd evaluate the 4 against the 5. Nums index j, which is 4. Okay. And how do we reduce so now temp goes down to the 5. Temp minus equals 1. Temp goes down to the 5, which is still less than. So the 5 would then go over to the 6 spot. Right, and then we would, once that becomes not true, so while it's less than, then once it becomes not true, you're going to temp goes down, the 5 goes over, 6 is already there, 6 is there, the 5 goes over. Now we're dividing a 4 against a 3, that does not equal to true. So we're gonna put what is here. This is index of temp plus 1. Nums 1 index temp plus 1 becomes nums index j. So you get to a case, now we need to insert, so the 6 would go over to here, right? The 5 would go over to here. The 3 would evaluate, that would break this loop, and we'd save the 4 here. because temp was reduced down to here. Try it. Might have an infinite loop, maybe. Oh shoot. Minus one. So we're using JI here though. So
beat is not sold until the check clears. Period.
So we'll get rid of this. Put this here. I equals to new m minus 1. J is n minus 1. So we need to reduce j at every iteration of that'll continue from there. I gotta go to the bathroom. I gotta go to the restroom. I'll be right back, you guys. Give me 1 second. Un momento. All right, we're back. Hello. Okay. So while new m is less than 2, I is equal to new m minus 1. If the numbers at index j is greater than the number at index I, then we're going to just put the value of m as j, the index of m as the value at the index of j, and nums 2, nums 1. So I is equal to this. And then we need to reduce j by 1. Then we say right, so then if it's not, then it'll move on. I becomes 1 greater than new m. Okay, temp is m minus 1. So this would be 1. So I wasn't used here though. So we could just use I again here, right? Rather than temp. Reduce I down.
Good job, Cooking Soul.
So we got new M.
I swear to God.
No, so this is gonna be, we need to save. And here. Right. So the 6 would go at 1, 3, 5, 6, 0, 0. M is here, and plus M is here. M minus 1 is here. On the 4, 4 shifts the 6 to here. To M. So we need to shift it to M. I don't want to shift it to this one to M2. I want to shift it to M minus swaps. Neat. Swaps.
Cooking soul.
Equal to 0. New M minus swaps. To reduce I down to the next value. Then you increase I, or put swaps by 1. If you get to a place where you can't do it, you put it I plus 1. Done. Infinite loop. Okay, so we're not increasing J, we're decreasing J. Wow. I gets decreased. So I gets decreased here to the next value to the left to evaluate. So we're stuck in this loop here. So J is less than nums at index I. Nums 1 index noon M minus swaps is 0. So we'll save at the new M initially. We'll reduce I down. let me take this here. This is number 88. One, three, five, 2, 4, 6. There's 2. M is equal to 3. So let's set this here. Index error. Nums 1 index m is equal to, oh, makes sense. So j is equal to 1. Why is j equal to 1? Numbers index 2. I is equal to 2, j is equal to 1. Why is j equal to 1? So new m is equal to m, which is 3. N is equal to 3.
Cooking souls.
M is equal to 4. Oh, so let me say. Okay, so nums looks like this. 1, 3, 4, 5, 6, 4. Y. Where do I paste that 4 at? 1, 3, 5, 6. Okay, so I pasted in 6. Uh-oh, 2 lines showed me up here. Showed me up for sure. Trying to just one up me then. Alright. So let's keep going. Huh, shoot. So let's set our breakpoint here.
Cooking souls.
Step into n equals 3, m equals 3. New m equals I equals j equals to 2, right? I is equal to 2. Perfect. Num's index m, which is 4, which is 3 in this case. We set the 6 there. Perfect. We increase new m, we decrease j, and we continue. Perfect. Okay. New m is 4. Those two values together are 6, so this still evaluates. I is equal to 3 now in this case. This if statement does not evaluate to true because the value of 5 is greater than the value of 4. Perfect. So now we move to this. Swaps is 0. Wow. Numbers 2 index j, which is currently the 1, the 4 value, is less than numbers index I, which is the 6 value. The 4 is less than the 6, so we're going to enter this loop. Perfect. So it's less than, so we need to take the value num's index equals to num's index j. No, not num's index j. This needs to be num's index of I minus 1. No. We want to save the value that we're currently on. Num's index j. No, sorry. We want to shift this value, num's index of I num's 1 index of I. So I is 3, 0, 1, 2, 3. So new m's is 4, so 6 will move to 4. There we go. No. Here, the 6 moves to the 4th. There we go. Perfect. Just like so. Now, the 4 in nums 2, I decreases down by 1. Okay, so I now becomes 2 at the 5 position. Swaps increases. Okay, now we have 2, 4, 6 still at 1, 3, 5, 6, 6. Now the 5 should move to that first 6 position. Right here. Boom. There we go. Decrease. Swaps increases. Now the 4 should take the place of that 5. Boom. Now I think at the end of this loop, I'm stuck. Oh, shoot. Oh, because we need to increase new m plus equals 1 here. And then we also need to decrease j down. Right, now let's start that over. We're going in, there we go. Get into now this loop, boom, making swaps. Now we're back into here. We're at 134560. We're on a value of I equals to 4. We're trying to evaluate to put in the 2 now. Pushes. Yeah, there it is. There's our answer. So now we need to say right here, if j less than 0, break. Right, so now if we run and debug, enter in, and we skip all this, keep going, till we get to the sorted array at the very end. One, two, three, four, five, six. J becomes minus -1. Great. So you could just go here and do that like there, and that'll be the same thing. One, three, 1, 2, 4, 3, 4, 5, 6. Break. All right, that's our answer. The debugger comes in clutch. I think we'll find out. Ah, edge case. Edge case! No, we solved 2! Okay. So if m is 0, numbers 1 is equal to numbers 2. What? Numbers 2 is equal to why didn't that one work? If m is equal to 0, numbers 1 equals to numbers 2. The array are merging. Anyone know what's going on here? Why? If m is equal to 0, in this test case, m is equal to 0. Oh, it's still doing this. If m is equal to 0, numbers 1 is equal to numbers 2. We're assigning number 1 equal to number 2 array. Do I need to make a copy of number 2? Oh yeah, I do. Because it's an alias. Oh. No. Doesn't make any sense. Anyone have any ideas? Besides my solution that's cheating by using sort, I'm gonna go back tomorrow and implement the merge sort. Maybe it's easiest to combine both arrays from the jump and remove the zeros, then merge sort. Yeah, I'm not sure. I mean, we have something working here, but I don't have this little edge case thing. I don't know why this isn't working. M is equal to 0. Let me save a first two as numbers 1. Yo, do you know why, Tim? This isn't working? Nobody? Nobody know why this won't work? So nums 1 okay, I want to see what's happening. Let me reload this in the debugger then. So let's make nums 1 be an empty array. This is 0. This is 1. Nums 2 has a 1 value. This has a 0. Equal to 0. What? Bruh. This should work. Like,
Cooking soul.
dude, does anybody know? Anybody have any idea as to why this isn't passing this edge case here? Anybody got any clues? I am solving Leet code problem 88 and I'm stuck on a edge case. It works in my local space, but don't show me code. But please assist in hinting to my error. But n is equal to 1. That's what I'm failing. For I will do times 1 top pop. For wow. Oh, that'll reverse it. Oh, that'll reverse it. And I do nums 1 equals nums 2 with a copy. Oh, I didn't know that.
Cooking soul.
Oh, so you can go like this. Nums 1, copy nums 2 up to n. Ah, to modify. I didn't know you could do that. I didn't know you could call a slice like this on the left side. So we might have some more edge cases though. one. This index. If J is this one. So it's just say like let's index out of range. Okay, so let's go here. Let's add in that little feature we had. Okay. Let's make our edge cases 2011. Two zero? How can that be? We're a non-decreasing order. Oh, 2 0. Oh. Okay, and then the zeros don't count. Here. This we should get that index there on the I. Let's see. I is equal to -1 now. We got while I greater than 1. Restart. Okay, 0. What is this print? 2 1. What was that? The song trip. What was that little number? Bruh. Okay, so we're hitting this. So so we say nums I plus 1. So if the I 0, here we save that as a 1. Yeah, new m is plus 1. J equals to 0. Wow. New m is 2. Say less than or, because we don't want to break there, we need to get one more less than or equal to. If J less than 0, we're gonna break. Hey Mateo, welcome dude. Welcome man, what you working on? Let's increase 10. So we are breaking. So the one. What's going on here is that J is 0, M is 1, nums is 1, J 0, nums 1 equal. We skip over it. Okay, so if you gotta swap the, so right now you have 2 0 and a 1. The I is at 0, so it's still good to index into. The J is at 0, so it's still good. Now, so this will say numbers index J, which is 0, so 1 is less than, so this will evaluate to true. No. Why? Oops. Numbers 2 index of 0 is the value of 1. Numbers, oh, I is equal to 0 here. Why is I equal to 0? I gets set because M is 1. Hey Toast, what's going on, dude? Welcome back in. Because new M is 1, so I get set to 1. No, I is 0. Okay, so at this point, let's go ahead and take. I am having some trouble solving some of the edge cases for problem 88. Don't show me code. You're off by 1. We don't want to do nums 1 m's Jesus. Nums index as soon as next. Incorrect placement of nums 2 J. Your condition nums 1 M equals nums 2 assumes that M is always the correct index replacement, but once shifting starts, M might not be in the right slot. Okay, so this needs to be so new M. Right. While the condition while I is greater than 0 means you're not considering I is equal to 0. When you say why is try.
Good job, Cooking Soul.
Print the state of nums one after each iteration. Okay, let's see what it says after those subtle changes. In nums1 new num. So we say new num's index I. When j is greater than I, you're assigning to new num. You assign it to is it I plus 1? Yes. Is there something right? Once the correct position for nums 2j is found, so I plus 1 here. Increase new m. So then here, if m equals to 0 block, here, copy. There's a lot of it. Whatever. If nums index j is greater than, assumes that I plus 1 is greater than index. This is either the while or for shifting. Whatever. I'm gonna move on. I'm done for the day on Leet code. Let's work on the project. I'm bored of it. Moving on. Alright. Small business manager. Let's go ahead and get into this. So what I want to work on today for the small business manager is the expenses tab and getting it up and running, similar to how we have the inventory tab. So I first do want to edit these functions for the add item though. Right. So let's do this. Add item to inventory. We get this, just like we do this. Status field, blank entry, return false. Yeah. We should make a 1-year montage. Yeah, I'm planning on doing a 1-year montage. That's a good idea. I want to get this project finished and maybe one more, and then include that in like a 1-year recap. Okay, so let's think here. So we're getting here if false, we get force title description. check the date, check the size, check the cost, accept value error. So in this one, do I match each case and I provide those. Okay, so let's do this. So here, try this, except for a, right, the date check will return the value error back to us for invalid date. So let's go here, value error as E. We'll go self dot add item status dot configure quote status E, right? We'll basically do this for the other things as well. So this is gonna be try, accept, we're gonna try, accept, right, status E. So here the status given is invalid date, invalid cost, invalid size. Then invalid dollar amount, invalid cents. Invalid cost, date, cents, invalid size. Okay, now we go back here. Now we'll say, that'll say status, invalid size, whatever, so we'll go exclamation points here. We'll delete this. This is try to get. Don't need that. Okay, because down here we just get. Right, and then do match complement. Okay, sweet. So now that should give us better error output messages. So if I go run this and I go here, failed, blank entry. Let's make that a exclamation mark to be consistent. Okay, then we'll relaunch this. What's this song? This song sucks.
Cooking soul.
Okay, it's not bad. What are you guys working on? Let me know what you're working on. So now let's run. Let's do status failed blank entry. Let's do date ABC, blank entry still, ABC, ABC, ABC. So this should be status. Huh, I'm getting this error. Value invalid date. Except for value, right? I thought it was capturing that value error. Unknown options. Oh. Text equals to this. Right. Okay, so now if we go ABC, ABC. Like that, add item, invalid, literal in for base. Refresh inventory. Yeah, distracted. When did you last check back in? Where did you last leave off? Hello, everybody. Thanks so much for joining me here. We failed on trying to solve a Leet code problem today. If you guys have any suggestions or tips, please don't share solutions or spoil things. No spoilers, please, please. I really like solving these somewhat independently, but I got stuck on problem 88 today for our daily Leet code problem, and I moved on to just working on the project because it was just taking too long here. So we're doing merge sorted array. This is what I have so far, but I'm not handling some edge cases. I was able to get my test cases to pass, but some edge cases for like different sized arrays and whatnot, I'm also he left off. Well, you guys got to come check back in. Come on, check back into the streams. If you guys are here, leave a thumbs up. My name is Michael. I'm 26. I have a degree in human bio and a minor in chemistry. I graduated from college back in 2021, and I work as a formulation chemist. I've been teaching myself how to code for about 7-8 months now. Every day after my 9-to-5 job, and I stream my progress live to you guys and really try to give an authentic, really genuine point of view of what it's like to learn these. Oh yeah, got you distracted, got you. So if you guys have any suggestions on this one, given my current attempt here, please let me know. But I'm definitely failing big time here on some of these edge cases. Oh, nice. Yeah, so I've completely restarted the project from scratch. So this is the old attempt, the SBM file I have here. This is the old one, right? Where you have main.py and you can run and you have the CLI, right? And everything. So I completely started over from scratch. I have, a bunch of classes I made, a database manager, item expense, obviously, transaction class. I have different tabs for all of these Tkinter tabs that I'm then importing into my app, that I'm using object-oriented programming within Python to create instances of these tabs, and then loading those in kind of as like a template almost. And so what I have right now is that we are currently trying to work through some bugs in terms of I'm trying to get some proper error messages to display here. So yesterday we did this, which was really cool, is now you can go to ID, you can select various headings from this drop down and then populate data, right? So if I give 1 here, I'll search, I pull up and refresh my matrix with the selected items. So it's really, really cool. It filters it out for you. I can go description, I can do test, search, none there, clear, right? I remember the stream where you delete the old project, start the new one. You were frustrated the DB not working. Now you look at yeah, exactly, right? So it's just like I struggle through it for a day or two, and now I feel pretty comfortable, doing queries and getting results and stuff from the database. So it's pretty sweet. Hey, Charlie. Hey, how's it going, Charlie? Welcome back in. So now we're not getting proper messages. This is failed blank entry, but if we give test, size, medium, cost 10, if I give this invalid date, but if I give ABC here, is it trying to do this? Yes, it is. Error refreshing. So that's catching. Why isn't that catching my? So my inventory tab in the add item to inventory function, we're getting a description. Oh, we're getting these values. If any of them are blank, you return this. Oh, it's because we're not returning false. That'd be why. That'd be why, brothers. That'd be why. You return false after each of these, so it doesn't continue trying to add the database and then doing this. So now if we go app.py, clear, run. Now if we go date, ABC, description, test, size, medium, cost, 10. Now we should get invalid, date. Okay, if I give a proper date, right, and then I give a bad size, invalid size. If I give a bad cost, invalid literal 10, for base 10. So the check cost returns invalid cost. This is trying to do this. So try to convert this dollars to cents, takes in an integer. So we'll say cost is equal to int cost. We'll take this out of here, take this out, accept value error. Yeah, accept value error. Cost of cents is this. We'll take this as well. Is that there? Raise, except if you get a value at any of this point in time. No, so, wait. This is the only thing that'll give you a value error, so accept value error. Invalid cost.
Cooking souls.
And then we'll do this. We'll call it raise value error. Okay, so if I go here, quit, run that. Oh. Accept value error. Oh, raise value error. Invalid cost. So now if we run. It's having an error. Where's ABC being added? No. Why is that error popping up? Error invalid. Okay, so let's go here. For the refresh, matrix. Try fetch all, clear. ABC. Where are you seeing ABC? It's not in my database.
Cooking soul.
Using Tkinter. First interview, dude. Good luck, man. You got it. You got it. I believe in you. Truly. Okay, so why is it giving us this error? So in the refresh inventory matrix, we're fetching all. If all inventory, then I'm doing this. I'm trying to convert a monetary value to integer. So it has to be in this conversion here on item 4. But it's refreshing the inventory though, which is weird. Right, is that it's showing me all of my items here, but yeah, so I'm not sure. Music's gotta pause while I charge my headphones real quick. Why is it giving me that? So I'm getting all. So I don't know, let me just, I don't know what it's doing really. ABC. Where is ABC? Oh. Oh, it still added it to inventory. I just had to refresh. Okay. Right. So if I run this now, it'll pop up. But when I add an item, ABC, 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 and add invalid date, go here, that didn't add it. Okay. I go date. Oh, I think they were in there before. So I think I fixed it now. So I go 2025 dash 03-26, add nothing. Okay. let's say all but the date, so test size medium, so all but the cost. That didn't add it in. Now how about all but the size? Invalid, didn't add it in. I think those were from the previous. And then, yeah. Okay, so now it's working appropriately. So now if we go ahead and add in an item, we'll make this distracted funny. We'll call it the size of a medium, cost, 1436, 26. There it is. Okay, sweet. So, nice. That's working now. So if you add an item, then we need to override the status. So in that add item to inventory function, if you're successful in adding an item before you return true, you say status item success item added, and then we return true. So now if you run that, we make a new item called, who wants to be Charlie? Charlie L. Description, oh, that is Charlie L. Date 2025 dash 03 dash, we'll give it the day before, 26. Right, then we go size medium, cost 1232. There you are. Now we can search, and item successfully added. Nice. So I want to add like a check though, I think would be good for like checking for a duplicate item before you add, just in case, right? You don't want to like add a duplicate item in there. So what we would do then is go so here, when you add an item, you get this information. You do checks. We're gonna go self dot. Oop, my caps lock is stuck again. Sticky key. Self dot database dot check duplicate item, and then given all of these, right? We'll leave off the status, right? Because it could be any status. So then we'll go to our database manager class. I'll go here and I'll go def check duplicate item self given a date purchased item cost size description, purchased. Right? We'll go query equals to select all from where right, column, where date purchased, item, description, so this guy here. Right here. I'll take this. Go here. Paste that. Option Z. This is gonna be select all from inventory where equals to that. Right? And we'll save that as duplicate item dot fetch all. Nice, Wolf. Congrats, man. That's super, super awesome. Super proud. That's so cool, man. Was it hard? Why does this have green and this one doesn't? db.execute, select all from inventory where date purchase, description. If duplicate, right? We're going to return duplicate. So if duplicate, we're going to raise a value error where we'll say duplicate failed. This stupid caps lock button is stuck. Duplicate. Right. Else. Else return true. No. Else nothing. So if you don't get a value error, you're good. So back in here, we'll say on the add item, right here, check duplicate item. Why did that not work here? I'm getting tired, guys. Why isn't that working? Oh, it's fine. Cost. We're going to try accept a value error as E. Self.add item message label text or .config text is going to equal quote status failed. Right. Return false. So check duplicate. So if duplicate and you raise and an error and also return a value. So we are checking for a duplicate. If duplicate, raise a value error, duplicate item. Return duplicate else false. So then we'll return the duplicate back. So what's this? If duplicate item raise value error as if duplicate item set this and return false. And we'll update the populate matrix tree with the items given. So we'll configure the message if duplicate item self.populate matrix via search with the item. Right? Populate it to show you the duplicate. Return false. Okay, so let's run. Okay, I'm gonna do a date, 2025 dash 2025-03-26. Distracted. Funny. Size medium. 1426. There's an extra. Oh, that's right. 2025-03-26. Description, test, or no. Distracted, funny. Size, medium, 1426. Syntax error. Values, select all from inventory where date purchased equals and cost. Okay. Equals this and description equals to this and size equals to this equals to this. So like that, is it like that? Okay, so then we'll remove that. No, need that. Self closes that, closes that. Select all from inventory where oh. Right, now we go date 2025-03-26. Distracted, funny. Size, medium. Cost, 1426. Object has no attribute, fetch all. What do you mean fetch all? Oh, so dumb. Bear with me, almost there. Here we go. This should be it. Medium cost. No. 1426. So we're getting the failure. Duplicate item. That returns 0. Returns false. Yeah. Boom. We got 2025-03-26. Distracted. Funny. Size medium. Cost 14.26. Status failed. Duplicate item in there. It's pulled up. Hey Armando, welcome in, dude. Professor put complex math problems but understanding the basics help. My takeaway so far in this math course is that we learn by doing and that there's a delayed learning curve. The faster we learn comes down, how fast we fail. Yeah, definitely. You know, trying things after failing is huge in this learning. Okay, so then that's perfect. So then should we add in another button below the add item to be like just for refresh matrix? Like they'll just basically call, like you can call the clear here to clear it back. Should we add a button like up at the top or like down below here? Like just refresh. Because right now when you try to add it, it gives you a duplicate right there. Right. Where should I put it, you guys? Below add item refresh matrix. Yeah, probably. Okay, let's do that. Inventory tab. We'll go here to the add item. Just gonna say button. So we'll copy down this button. We'll add this to row 7, make this row 8. Might just be refresh matrix. Command is going to be refresh inventory matrix. This button keeps getting stuck. Okay. Now we need to go and allow for the frame to have an 8th spot. 8. So this is going to be the add item button. This is going to be the refresh matrix. Right. What's in row 1? Nothing. Spacing. Right, so I go app now, run that. Now you have refresh matrix right there. So if I add in a duplicate item, 2025-03-26, distracted, funny, size, medium, cost, 14.26, add item, failed, duplicate item, and then you can refresh. Right there. So we'll make that rather than matrix, we'll just say refresh. Perfect. How's that look, guys? That looks awesome. Right, so now you have refresh and add item right there. Can you specify the size no matter what? So you can make these buttons the same size. Can you, let's see, width on the button. Inventory tab on the button here. Right. On the button here, we're going to make the width equal to 50. We'll see what that looks like. Really big, so let's cut it in half, 25. Huh. See, it's really big. Let's go 10. It's bleeding off. Okay, there we go. I like that. Let's make it a little bit smaller. Make it like 7. There we go. And I'll make the other one 7 as well. This button here, search and clear. There. Now, all those buttons are the same width. Nice. Looks really good. This looks awesome. Awesome. Okay, so our next goal is going to be to do the expenses next. So that's going to be it for the inventory. We have the ability to add in items. We are appropriately getting error status messages back to us via this label here. And then we have the ability to also refresh the matrix if needed as well on duplicate. And then we also will be checking for duplicates. Then you can also provide a heading, specific heading, and filter for a specific value with that heading. So pretty cool as well. But I believe the inventory is all good to go here. So let's see, we have add item. This is column span. This is a button. What about the label here? Font, justify center. Anchor. Center. Not too much. Oh well. So though, why am I here? I got 0 through 8 on the add item frame, but here I'm going 0 to. So let me go. Let me make this 1. Zero, 1. Row 0, 0, or row, sorry, this is row 1. Row 1, row 2, 2, 3, 3, 4, 4, 5, 6, 7. Okay, that didn't change at all. It just made it a little bit more even. Actually, that looks good now. So now if we go inventory manager, is the same thing happening to the search? 0, 1, 1, 2, 3. Right, because this is the entry of this combo box. This is the button. 0, 1, 1, 2, 3. For the 2 buttons, 4 for the label. Right, and then 0, 1, 1, 2, 2, 3, 3, 4, 4 for the entries. Button on 6, label on 7. Perfect. All right, you guys. So that marks the official completion of the inventory page. So, woo, leave a thumbs up on the stream for that. We are completed the inventory page. We can successfully add items to our inventory via their date, description, size, and cost. We are appropriately doing checks across these parameters for specific, expressions. So dates have to be a certain format. Descriptions can be any string. Sizes have to be within a certain set, and the cost has to be a certain integer type. It can have a decimal in it. It's given as a string, but then we parse the string and pull out the dollars and cents and convert to total cents for the database. Then when we display, we convert that back into dollars. So we don't have to use floats, we can use integers. Then also, if we try to add an item with duplicated statistics across the date, description, size, and cost, we will pull up a duplicated item. For example, 2025-03-26, description, distracted, funny, size medium, 1426 for price, add item, failed, duplicate. And the status search was made success, items found on the populate. So hold on, let's go to the populate. This is changing the label here for success, items found. We'll say via duplicate. And then we'll come down here. We'll copy this down basically and then make this via duplicate. And then set this status this is going to be the add item. Set status. So if you populate, you do the duplicate, and you return true. So you'd only call this if you get the duplicate. So you'd override the add item label to be status failed duplicate item. So you wouldn't have to do it here because the populate duplicate does it for you. Right? So now, if we run app.py and we find a duplicate, it should update our status here, not down here. So if we go 2025-03-26, distracted, funny, 1426, oh no, 1426, size medium. Now if we add this, it should give us duplicate here and not here. Perfect. Status failed, duplicate item. And then it pulled up our duplicate. Now you can refresh and pull back up your inventory. Woohoo! All right, that officially marks the end of the inventory item page. So from here on out, it's kind of downhill for the next two pages, expenses and transactions. It's very, very similar makeup, backbone, and structure, just implementing just different tailored functions for querying the inventory, the expenses and transactions databases rather than the inventory. So we're going to be doing the insert into, the selection, and the checks across the expenses this time rather than the inventory items. And so it's the same exact makeup and setup from this page here, but just for tracking different type of object. And then the income statement and balance sheet, those will be different in their entirety. I still have to come up with the how I want to design those. But so the inventory page is kind of done, which is super awesome. We completed this in pretty quickly relative to our first iteration of the project as a whole. So we can, like I said, we can add items to inventory. Those new items are populated into our matrix and refreshed into our database. That there's checks across these various inputs to make sure that the expression is correct for our input in our database. We then add the item. If the item is a duplicate and is found to be a duplicate, then we go ahead and display the duplicate, to the user, such as this right here, and the status displays failed duplicate item. We then can refresh the matrix to refresh, and then I will just say we need to also add, I keep forgetting stuff, on the add item status here, when you press the button for the clear inventory matrix, no, not clear, on refresh. So what do I call? I call refresh there on the add item button. Oh, so this is refresh matrix button. Right. Yeah, refresh matrix button, refresh. The command is to refresh the inventory matrix. On refresh, we clear, we fetch, we clear, and we populate. After we populate, we set the self.add item mestatus.config.text config text equals to status none. Right, so we'll reset that one to default, and then we'll also, on a refresh, reset the search one as well. Right, so that's what happens on a refresh. Then on a so clear calls a refresh. We're doing the clear on the populate. We're calling a right, so then if we call clear item search, where is this being pulled from? What is this being used in here? On the command clear, we're calling refresh and then setting this reset. So that'll make it none. So in the refresh, if we refresh the matrix for all, right, we clear to get rid of, we set both statuses to none, and then it gets just overridden here to matrix reset, so it should still work fine. Oh. On line 201 here. Add item status message label.conf. What? Add item status label on 201. What? What are you talking about? I have it right here. Oh my gosh, come on. Why is this working? I have it right here. Add item status message label. So on a refresh, you reset both of them back to normal. Why isn't this working? So in my add item status message label, add item status message label on line 201. No attribute search inventory status label. What? Matrix reset, refresh status none. Refresh matrix. Clear item search calls. I don't know why. Why wasn't that working? That didn't make any sense at all. Because I am doing this. Why isn't that charging? I've had this on the charger for an hour now. What are you talking about? My AirPods are still dead. What? How? So when you add an item, you refresh all. This clears. This is the command for item search. This clears the item search. This calls refresh, which calls clear. Right, so I run app.py right now. Refresh has no status change, but clear does. So the clear button does the command here. We call refresh, and then we change the self. So in refresh, self dot They don't have self in front of them? They do. I have it. If the read is called before. Oh. Calling refresh. Huh. That's why. That's what we'll do. inventory. Refresh, you do that. Config. Remove this. Load all inventory on the initial matrix. Load. Then you call refresh here. That'll work either. Huh. So we have the matrix button is calling call before. Okay, so this button cleared on the search calls clear item search, which refreshes and then makes the status matrix reset. So in the app, on this, matrix reset, status refreshed. So on the clear, add item, on the clear, call refresh, we call load inventory matrix. So if I go apply, run that here, clear, matrix reset, status none, but refresh, both of them matrix refreshed. Status none. So let's go to the refresh button. I'm calling on refresh, the status for search is none. Go app.py, run, refresh, status refresh, clear, matrix reset. I do a search ID for 1, search, success, clear. It's not resetting. Clear button's not working. So clear calls clear item search. Clear item search loads all inventory from the matrix. Load all does a clear and populates. Search ID 1, search, clear. Refresh works. Inventory, what's the difference? All, clear, Insert the thing. Return true, return false. Clear. That's why. Matrix reset. 2025-03-26. Description: distracted, funny. Size medium, cost 14.26. Add item. Failed, duplicate item, refresh. Status none. Okay. Right. So what you do is you have, this is what loads it initially. This is what happens on a refresh. So on a refresh, we can just call insert if true. So we can just call this. Right? Value. So that'll call just the load, the clear. So on the refresh, we can just call load, which will do all of the above, and then we can populate on the refresh just these. So when you refresh, both of them gets refreshed. When you load, it does nothing because it's defaulted. So then populate, not calling anything there. Populate, not calling anything there. Just give me a different message label. Right? So then we're calling refresh and load. Where else is load being used? Anywhere in here? On the clear. Calling load, matrix reset. Okay, let's just, the refresh button on the, right, is calling refresh inventory matrix, which is here. It's calling load and then setting these to refresh. Whereas the clear button is calling clear item search, which is calling this, and then this, calling load. So I'll just do, we don't even need this then. Don't even need that. we just need to go here then, and then do refresh inventory matrix. So now if we go app and run, we press refresh, status refreshed across all of them. Unclear. So I guess I'll just go like this, and rather than having in the inventory manager, in the search, we'll make this refresh as well to clear out search item refresh, clear button. Add item refresh matrix button. Right, and then we have search item refresh matrix button. Right, so that'll both say refresh now, and then this will call refresh as well as that one with 7 text refresh. Cool. So now if we go app and run, they'll both say refresh and both do the same thing. Right, and then you can search failed, add item failed, refresh, set it refreshed. So if I go populate here, day purchased 1, search invalid, or ID 1, search, refresh, populates it all back. If I do date 2025-03-26, distracted, funny, size medium, 1426, add, failed, duplicate item, refresh, status refreshed, perfect. All right, I think that is solid. We did some bug fixing and did some final adjustments, and now, now an hour later, I think the inventory tab is completed. If you guys have any suggestions or bugs you guys are seeing, please let me know. But we could visually display a $sign in front of here, you know, to have that also be something. But in terms of like editing though, there is no opportunity to edit the information. So that being said, is I know that you can add in some parameters into Tkinter, so I can like double click and be able to access and edit this data. Now, it's going to be difficult, so I might need to, you know, continue add on features, or they might just have to edit within the file or something. You know, so we'll see. But yeah. So this works, refresh. Yeah, sweet. So now you can add in items. So let's say we added in test. Adds it in there. Refresh. Go description. Test. Search. Pulls it up. Refresh. Sweet. All right, guys, this is going to be it for me today. Thank you so much for joining me. If you guys are here, part of the late night crew, please leave a thumbs up on the stream. It really, really helps. I'm streaming learning Python and computer science live every single day after my 9-to-5 job as a chemist. Thank you guys truly for being here and joining me. We got stumped on a Leet code problem that we couldn't solve earlier, unfortunately, but hopefully we'll get another stab at it in the future. And then we worked on completing the inventory tab here for our small business manager program and project. So we will work on translating pretty much a one-to-one kind of transition over into the expenses and transactions for the actual framework. And then we'll work on income statement and balance sheet from there. So thank you guys so much for being here and joining me tonight. I'll be back tomorrow to continue on with expenses and transactions tabs, where we'll go ahead and finalize all of these features here and get them actually working appropriately. And then just like we did for these other ones. So this should be pretty easy.